there we go. Okay, that's better. Okay, cool. So otherwise, I cannot see people typing anything in the chat while I'm sharing my screen. So hello, good morning, good afternoon, good evening, wherever you are. I'm excited to be here. Thanks for having me, and thanks for making the time to out of your busy schedule to talk about something that we've been working on for a while now called visual calculations. So I'm Jeroen Heerdt. I am a principal product manager on the Power BI team. I focus mostly on DAX and DAX related topics. So you might have seen me in maybe some conference or maybe somewhere online. You might have seen my picture at like the Power BI blog. So mostly what I do is I try to figure out what is the future of these features, especially in the DAX space. So as a product manager, I figure out what is the plan, what is the feature going to do, and then I work with software engineers who actually build software and architects who actually make sure that everything, fits together. And so they actually built the software, and I represent the voice of the customer, right? So trying to make sure that I built the right solution, we together built the right solution for you all. So one of the problems that we've been seeing in DAX is honestly that DAX is pretty tough, right? It's pretty tough to work with. It can be simpler, and that's the reason we started on this journey, is to try to make DAX a bit simpler to work with, without making it too simple, right? So the goal is not to get rid of DAX or to remove the power of DAX, right? We're trying to find a way that we can give more users the ability to work with DAX by making it easier without taking any of the power away. So that's really why we started with visual calculations. This is a journey that we started on 4 years ago, about 5 years ago now. So it's been a long time, and this has been in public preview since February of last year. So it's now, I think, on the day a year in public preview. I think I remember it correctly that it was the 14th last year that we put this in public preview. So it's going to be exactly a year now, which is exciting. So today we're going to talk about visual calculations, what they are. We'll give you a demo, but first let's start with why we're doing this, and then feel free to use the chat. I'm monitoring it, and then we have Q&A at the end as well. If you ever want to reach out, I'm here. You can find my email here and my social media handle. I'm on Blue Sky, which is a social media application. That's where I'm on. I'm also on LinkedIn. I'm no longer on Twitter or X, so Twitter is my X social media. So this is how most people write DAX today. It's basically you find something online and you copy paste that information, and then you paste it into your Power BI desktop environment or your web environment, and then you hope for the best, right? And this is really interesting to think about this as the way to write DAX, because it's the truth, right? And it's interesting that if you get started with a visual with a tool like Power BI, which is supposed to be a self-service tool, that you have to learn this programming language that many people think is very hard, and you have to take training, you have to read the book. So you find some book online, you find some physical book about, for example, the one that is, of course, very popular, the Definitive Guide to DAX by the SQL BI folks. And you read that, you read it again, and maybe you read it another time. You still don't quite get it, but you can use it, and you kind of feel a little bit empowered to use some of DAX, but you still don't feel like you actually understand it. And that's really where a lot of customers are. Is you find something, you think it's the solution, you copy paste it, and you hope for the best, right? And of course, we have other tools in our toolbox. We have quick measures in Power BI, but really the DAX it generates is still pretty complicated, and it begs the question: how are you going to validate the output of that DAX if you don't understand the DAX to begin with? So, and this is really an interesting situation that we have this self-service BI tool that is supposed to be very easy to use, and then the programming language that you have to use to do calculations, called DAX, is so hard to use, or at least perceived to be so hard to use. So that's really the core problem we're trying to solve here, is trying to figure out how can we make this easier without taking away flexibility, without taking away the beauty of what DAX is and what it allows people to do in terms of making all these calculations that they want to do. But how do we make it more easy to do? So, for example, what is really hard to do is a running total. If you ever try to do a running total in Power BI in DAX and you started searching for how to do this, you very quickly end up on this website that lists 21 steps to doing a running total in Power BI. Now think about this. A running total is not rocket science. It is literally just a sum, right? You only need to understand addition. You don't need subtraction. You don't need division or multiplication. You don't need even more advanced math. You only need the basics of math, which is addition. You need the ability to add two numbers together and do that over and over and over again. That's the only thing you need to do to get a running total. So then why does the world's leading self-service data visualization and analysis tool make it so hard? Well, the core problem is that DAX doesn't allow you to actually refer back to what came before, which is what a running total really is, right? A running total is really start at the top, get that number, go to the second row, take the number from before and add your own value, return that value. Go to the third row, take the value from before, add your own value, return a value, right? So it's based on referring back to what came before. And that is surprisingly hard to do in DAX. So 21 steps. And your customer, yourself, or your client or your manager might go like, why is this so hard? You can do this easily in Excel. I can do this on the back of an envelope with a piece of paper. It's very simple, right? Why is Power BI making this so difficult? And that's because it is very tough in Power BI, again, to refer to what came before. And that's really the core problem here. So DAX is hard. And to be exact, most people struggle with a little something we call filter context. And filter context is the environment in which measures and any calculation, measures, sorry, in DAX get evaluated. So what does that mean? It means that if you look at a measure statement, let's say sum of sales amount, that same measure statement might mean the total sales of all products across all the years in all countries in the world where we sell products in our data set, or it might mean the total sales of all yellow products in New York yesterday, right? So that exactly same statement might mean two completely different things and everything in between, based on the filter context in which it's getting executed. And we don't show you that filter context. We don't explain it to you really well. It's really hard to understand. And it's based on this data model that creates this filter context for you when that measure is being executed. Now, that is just the reality of what makes DAX hard, is that the statement you read does not necessarily tell you what it will return. And then, as I said, like typical business type calculations are surprisingly hard to do. Quick measures exist, but the DAX it generates is hard to comprehend and to edit. Referring to what came before is actually the reason why typical business type calculations are really hard to do. So this is the core premise of what we're trying to solve and what the issue is with DAX. So we try to come up with, okay, how do we meet this challenge? So what if we could do away with this complexity without sacrificing any of the power? What if we could potentially come up with a way that you could hide this filter context for a while and get rid of that while still having it if you need it, but when you're working with basic calculations with like in your visual that you're building calculations for, you don't need to worry about all this complexity. So we basically said, like, instead of requiring you to do the calculation in the model where you have to deal with the filter context because it lives in the model, why would we not allow you to do a calculation later in the pipeline? So what do I mean with pipeline? The pipeline is all the steps that Power BI takes from getting the data from their data source, whatever data source it might be, and painting visuals onto your screen. All of that is the pipeline. So it starts with retrieval of the data from memory or from the data source. And then it models it. It performs calculations like measures. They live pretty much in the beginning of the pipeline. That's where filter context lives. But as the data progresses through the pipeline, the data gets aggregated. Because we are not in the business of consuming millions and millions of data points. We are in the business of summarizing data, right? Most humans cannot remember more than 7 or 8 data points at the same time. So we are all in the business of creating charts to summarize the details away and spotting trends and highlighting important stuff in charts. So really in the pipeline, the data is aggregated from raw data into high level information. And in that pipeline, we allow you now with visual calculations to add a measure, a calculation later in the pipeline. So measures today live in the model very early in the pipeline. That's where a lot of data lives. That's where the filter context lives. But as the data progresses, it's aggregated. And then Power BI starts painting, let's say, a line chart or a column chart onto your screen. At that point, the data is aggregated away. There's only a couple numbers remaining, might be millions of source rows over here, doesn't matter. It's just shown a couple data rows in here in the chart. In here, then, we allow you to do calculations. And by doing that, the amount of data that you work with is very simple because it has been highly aggregated and the filter context has been applied. So what if we could do that? And that's essentially what visual calculations are. So they are not a new language. They are just DAX calculations defined on a visual. And they can refer to anything that's on the visual, including other visual calcs. So you can build a visual calc on top of a visual calc on top of a visual calc. They are executed in scope of the visual, not in the model. The reason for that is because by doing that, we get rid of the filter context. You don't have to worry about that complexity. You only work with what you can see. It's very, very simple to understand. And then because of us now having a DAX construct inside of a visual, we can do stuff that measures cannot do. Because measures, they don't know why they're being executed. For all intents and purposes, a measure is part of a database. And the only thing it does, it gets queries. And it doesn't know if you're creating a pie chart or a line chart or a bar chart or a table. It doesn't know why you're executing this. It's just, oh, you're executing a query and I need to run this measure. Great. This is what I do. I give you a tabular structure back. What you do with that tabular structure in Power BI, that's up to you, right? So then Power BI creates a line chart. So with this, with Visual Calcs, this understanding of a calculation can actually refer to the visual structure because it's aware of the visual structure in which it's being executed. So it can do some interesting tricks, which we'll see. And then most of the time, you don't have to worry about the complexity of filter context. Now, you might be familiar with other ways of doing calculations in Power BI. We already have calculated columns. We already have measures. I know there's some people in the community that think that we shouldn't be doing calculated columns. That's not the topic for today. So we have both. We have calculated columns and measures. Visual calculations are just a new tool in your toolbox. So we're not taking any of these away. Our recommendation is not changing. You can use all of these 3 tools, but the way I like to think about it is that visual calculations are actually the best of both worlds between calculated columns and measures. So calculated columns are great in the sense that they're easy to write and understand because they operate mostly within the same table. There are a column on the table, they go row by row by row, so it's very easy to check your work. They have downsides, of course, that they are pre-computed, they bloat up your model, they're not very flexible. Measures are really flexible, they don't bloat your model, so they are awesome, but they are defined in the data model, they have to deal with filter context, so you really don't know what the result is going to be of that measure. It's really hard to test your results and understand how they work. With visual calculations, we actually take the best of both worlds and we say, hey, we introduce a model that is row by row by row, very simple to understand, very visual to understand how this is done, but it's not being pre-calculated, it's calculated on the fly like a measure. So we take the easy of use from calculated columns, we take the on the fly definition of measures and put them together, and that is what a visual calc is. And on top of that, it can do more stuff that the other two cannot do because we are now introducing a concept that is part of a visual, so we can refer to that visual structure. So I like to think about DAX as a swimming pool. So measures, if you just know about measures, then the DAX swimming pool is pretty deep. And when you jump into the water, you better know how to swim, otherwise you sink. And what I mean with learning how to swim is you have to take training. You have to go online and find help. You have to go read books. That's what I mean with getting help and learning how to swim. With visual calcs, what we're doing is we're adding what I like to think about as a kiddie pool. to the pool. So it's a shallow end to the pool where you can just wade in, get your feet wet, get your knees wet, get your middle wet, and then when you're ready, if you're ready, you can start swimming, right? So instead of throwing you into the deep end and go, good luck, right? We actually say, no, here's an easy way to get used to this kind of thinking. And then once you're ready, you can always go to the deep end. There's nothing stopping you from going from the shallow end to the deep end when you're ready, or come back and go back and forth. That's totally up to you. You can stay in the shallow end all you want. You can leave and go to the deep end and never come back. That's fine as well. But it's just an introductory level into swimming that you don't have to start swimming right away. It's how we teach kids to swim, right? So Visual Calcs just makes it easier. Now, I'm convinced there's a lot of stuff the Visual Calcs can do that are actually better than what measures can do. So even people that already know how to swim might want to come to Visual Calcs for the shallow end a couple times, just to make things easier, make it faster to achieve their goals. So visual calculations are easy and flexible. What you see is what you get. So the thing you work with is what you work with, and that's on the screen. And they have specific tricks that we'll go to in just a second. So I will skip over this slide, but the next slide is the most important one that I need you to remember, because that is what makes Visual Calcs work. So the mental model that we're introducing here is that any visual that you ever create in Power BI can be represented as a matrix. So think about it. If it's a line chart or a map or a column chart, it doesn't matter. All the visuals you ever created can be represented as a matrix. So that's essentially what we're doing. So we're taking that visual that you're working with, and then we're saying, hey, I'm going to convert that into a matrix, and I'm going to show you the visual and the matrix, and we call that the visual matrix. We're going to show you that, and then a visual calculation is an extra column onto that matrix. So here on the right, you see a mockup. We see the a chart, right? So we see our little chart over here. You see that it shows 3 groups, 1, 2, 3, and it shows 2 measures, right? So 1 and 2 for each group. So it has 6 bars in total, 3 groups, 2 measures. So how many rows does Power BI? What's the data structure that Power BI needs to paint this visual onto your screen? It is just 3 columns and 3 rows, as you can see here at the bottom. 1 column for year, 1 column for sales amount, 1 column for total product cost, which are the 2 measures that I'm showing, and then 1 row for each of the categories with the category name and the values. That's all it needs. There might be millions of rows under here. There might be millions of rows in the data set that together sum up to sales amount and total product cost. I don't care at this point. At this point, when we're painting the visual onto the screen, all of that is out of the window. I don't care if it was multiple tables, 100 million rows, from whatever source, I don't care. At this point, Power BI is just interested in showing these high-level numbers to your screen. And on this level, we then allow you to add extra calculations by extending the visual matrix with columns. So that's essentially what visual calcs are. They are just extension columns onto this visual matrix that we show you. Okay, cool. So with that out of the way, let's look at a demo. Let me just switch over. Okay, so you should be seeing my Power BI desktop now. This is not a trick. This is literally just my Power BI desktop. There's nothing special in here that's different from my version to the one you have on your machine. You can also do this in the web, but I'm just doing it in desktop. So I'm going to replicate the same thing that I just did seconds ago. So this is now a matrix. I'm going to turn that into a column chart, and I'm going to sort that by fiscal year. So it's in a nice chronological order. So it's essentially the same chart that as I just had on the screen, right? Like one category, fiscal year, 1 group, right? 3 groups, FY 2018, 2019, 2020, and then 2 measures, total sales and cost, right? So now on here, I can select this and go, well, I'm going to create a new calculation. So once I select the visual, this new button over here, the new visual calculation button, will automatically be enabled. So you select the visual, and then you have a new button over here. Once you click this, you will enter in what we call the visual calculations edit mode. Now, this should feel very familiar because it's essentially what I just showed you on the slide, right? You have the chart, you have the visual matrix, and as you can see, it matches, right? So here it's 23 million something. That's exactly the number that's over here. This bar is 51 million something. That's exactly the number over here. We also added a total row. We're not showing that individual, but we're showing that anyway because it makes most calculations easier. And then you see an inviting calculation column over here, which allows you to then extend this this visual matrix with calculations. So what we're going to do is we're going to add a calculation. So let's do one that I know should have been a measure in this model, but I'm just going to do it anyway, just for simplicity. I'm going to call it profit. And profit is equal to total sales minus cost. Now, before I press enter, a couple things to note here is I'm not referring to the table. I am just referring to what I can see here, literally total sales and cost. So I'm using the names that are the names on the visual. At this point, if this came from sales or from another table, doesn't matter. I'm just working with what I see on the screen. Also, I'm not using aggregates. If this was a measure, I would do sum of total sales minus sum of cost, right? But I'm now literally, because this works row by row by row, I can just write the stuff that I see. So will this work? Well, yeah, of course this works. And now I'm calculating a profit that subtracts this from this and returns that for every single row, including the total row, right? Cool. Let's do something more intelligent. Let's do versus previous. So I want to get the difference in profit for each year versus the previous profit, right? So for 2018, there's no previous year, so the profit is 13 million. The difference, but for 2019, the difference would be 22 million something minus 13 million something. And for 2020, it would be 30 million something minus 22 million something, right? So I'm going to calculate the difference in profit across the 3 years. So I'm going to call this diff profit. So first what I need is I need the profit. Okay, got that. And then I need to find the previous profit. So what I'm going to do is I'm going to need a function that allows me to get the previous value of the profit. So I'm just going to guess. I'm going to say this is called previous. And what I'm going to say is give me the previous profit. So get me the profit from the previous row. Will this work? Well, it's almost like English, and this will absolutely work. And it's now calculating the difference in profit across the 3 years. Okay, let's do something more exciting. Let's do a running sum first. So we have this FX button over here that you can use. It allows you to pick templates, which is basically like easy to discover ways of working with this tool. You don't have to use these, but it's just, easier way to discover what all you can do. So in here, I also find a running sum template. So the running sum is not easy to create, but in Visual Calculus, it's very easy. You have a specific function for it called, as you might expect by now, running sum. So I can just call this running sum, and I want to do a running sum of profit. So then click enter, and this is a running sum of profit. And I can do a moving average. Let's do a moving average. Well, you might guess by now that the function name for moving average is also very descriptive. It is literally just called moving average. So I'm going to do a moving average of profit. And then I need to specify a window size. Window size means how many rows do I want to take into account. So window size of 1 would be kind of boring because it's an average of one value as the same value. So I'll do a window size of 2. So then that means for 2018, I'm expecting this value. For 2019, I'm expecting 22 million and 13 million as the average of those two numbers. For 2020, I'm expecting 30 million and 22 million, the average of those, right? So that is basically how this window works. Will this work? Yeah, of course this works. So now I have a moving average. Very, very simple stuff. Now, I'm not a big visualizations guy. In fact, the next speaker here at this user group will be our visualizations PM. So please bear with me on that one. So don't expect me to build great, awesome visualizations. But even I can tell that this visual is not great. So in fact, I didn't want to show all of this. The only thing I wanted to show is actually show the difference in profit over the years, the running sum and the moving average. So what I want to do is I actually want to build a visual that just shows those things. So my first instinct might be to delete stuff, right? So I don't need profit, I don't need cost, I don't need total sales. I only need to show difference profit, running sum, and moving average. But remember, Visual Calculus can only refer to what is on the visual. So if I remove total sales, it will break because, well, profit refers to total sales. So then If profit cannot be calculated, difference profit cannot be calculated, running sum cannot be calculated, moving average cannot be calculated. So I need to keep total sales, I need to keep cost, I need to keep profit. So instead, what I'm doing is I'm going to hide it. So here on the right, you can see that you have familiar icons that allow you to hide stuff from the visual. So once I go and click that, then you'll see that the visual changes. The visual matrix doesn't change because the stuff is still in the visual matrix, but it's not shown on the visual. And then I can move things around. And I'm sorry, I'm not seeing this. I need to just go, yep. Okay, so I'm moving average and my running sum to the tooltips. And then I'm going to go back out. And now I've created the visual I was after to create a visual that shows the difference in profit, the running sum, and the moving average. Very, very powerful insights that I was able to build using four very simple, arguably very simple lines of DAX that were very hard to do before. So this is why we're doing visual calcs, to enable you to build all these powerful visuals and insights very, very quickly and very easily. Cool. So with that wraps up the demo. So just to hammer home the point, what are visual calcs? They're just DAX calculations in scope of a visual, and it's just DAX. It's not a new language, and most DAX will work. So if you have a simple switch statement that divides your sales orders into order categories, small, large, and medium, which is, for example, you implemented as a calculator column like this, you can copy paste this into a visual calc, it will just work. Basic arithmetic will also work, and we have special functions that are new to visual calc. So why is this exciting? Well, here's how we would do a running sum calculation that sums sales amount over year. Without a visual calc, the first statement in DAX is what you would do. So it involves a calculate, a sum, a filter, all selected, is on or after. It's not the hardest DAX in the world ever. I agree with that, but it's also not the simplest. And with visual calcs, it's just literally called running sum. That's all you need to do. Let's do a more intelligent one. Given a list of states and a number of restaurants per state, we each calculate, for each state, calculate the difference in the number of restaurants in that state versus the one above. So this refers to what came before me. So the DAX here on the left is the original statement you would have to write, which includes a summarize, a selected value, and a top and one. This is pretty complicated. To be honest, I wasn't able to write this. Then on the right, the top right, that's how you would do it using window functions, which makes this simpler. Window functions are stuff that we introduced in December 2022 that makes this calculation a little bit easier. And that's actually the secret sauce on which visual calculations was built. So you see it uses offset -1 to calculate the difference between my current position versus the one above. Offset -1 meaning going one row above me. And then, of course, visual calculations, bottom right, makes it even easier by saying diff is number of restaurants minus previous number of restaurants to just make it even easier. So we are introducing new functions. So we already talked about some of these, so let's go into it. So low-level functions are the functions that you can use in measures, in calculator columns, and in visual calculations, so you can use them anywhere. Offset, index, window, rank, and row number. And these have been around since December 2022. If you go back and reread the blog that I wrote at that time, I was alluding to what we were building with visual calcs, but I wasn't ready to talk about it yet. But essentially, these are the functions that kind of like build the foundation for visual calcs. So they allow you to do a relative movement or an absolute movement or define a slice of your data, which you actually need to do a running sum or a moving average. And they're supported by order by and partition by and match by. So it's not as easy. I mean, they're easier to use than regular DAX, but I think it can still be easier. So that's the next level. We build specific functions that are only available in visual calcs that makes it even easier to work with, right? So previous allows you to move up or left in your matrix. Next moves down or to the right. So it's a shortcut to offset, which is a relative movement. First moves to the beginning or to the end. So that's an absolute movement. Index, shortcut to index. We have expand and collapse, and the variance that allows you to walk up and down a hierarchy. So if you want to do an average of children, you need an expand that for that calculation adds more detail. If you want to do a percentage of parent or a percentage of grandparent, you do collapse, you remove detail. So is that level then allows you to inspect if you're on a subtotal or a total row to return different results. And then range allows you to define a slice. And then last two new functions that we have is running sum and moving average, and we've already seen both of them, right? Making it easy to build running sums and moving averages. Now, a couple new concepts we need to talk about. Visual matrix, we already talked about, right? It's a matrix representation of the data in a visual. Simple. Axis is actually the stuff that I've been using, but I haven't shown you yet. So we'll talk about that. Axis defines how a calculation, when it's being calculated, moves over the visual matrix. And then reset defines, as the calculation is moving over this visual matrix, does the calculation restart at any point? That's what reset means. Direction is just thinking about reset and axis together. Hidden, I already showed you the ability to hide a field from the visual, but not from the visual matrix. Okay, so axis. I've been working with axis all along, but you didn't see it because axis has a default value and it's called rows. And we actually show you these icons in the product. So think about axis as how the calculation moves over the visual matrix. So by default, it is set to rows, which means from top to bottom across the rows. So you'll see these downwards pointing icons in the product as well. That means the calculation is calculated row by row by row. You can also switch it to columns, which then says I'm going to calculate the calculation column by column by column, left to right. You can also combine these and do, for example, a snaking movement, an N or a Z pattern across your visual matrix, which arguably is pretty advanced and not very common, but we put it in anyway. So just to give you an example of how this works. Let's do a first sales amount on rows. So for each row, retrieve the sales amount from the first row. So look at the colors here. You'll see the dashed lines refer to the solid lines. So what this does is for each column, so I have 2018, 2019, 2020, so the fiscal year in the columns, I am getting the first sales amount, right? So that means that the calculation will just return one static value, which is a sales amount for the first category in that year. So that's accessories is the first category. So for each year individually, it will return the sales amount for that category over and over and over again. Right, so it's a static jump. Regardless of where you are in this matrix, you will always get the first value, which is accessories. So that's rows. Now we can do a 90-degree turn and say first sales amount on columns. So for each column, retrieve the sales amount from the first column. So look at the colors again. Instead of now going year by year by year, we're now going across categories. So now we say we are going to retrieve the sales amount for the first year, right? Because that's columns. So we're now going to get the sales amount from the first column. So color codes meets up. So every single calculation now gets the sales amount for the first year, which is FY 2018, within each category. More advanced scenario, let's do previous sales amount on rows columns. Means for each cell, retrieve the previous sales amount from the row above it or from the last cell in the previous column. So what this does is it will just return. So this cell is empty because there's no row above me, there's no column to the left of me, there's nothing I can return. This cell is not empty because there's a row above me. Makes sense. Give me the value. This one is not empty, row above me. This one is not empty, there's a row above me. This one is not empty. There's no row above me, but since I wrote rows and columns, I'm allowed to take the value of the previous column, the last cell. So this one is now returned here. Then we continue on a happy way. So in a lot of ways, this is a snaking pattern going across the rows and then over the columns, right, in an N movement. And then, of course, we can also do 90-degree turn where you have columns rows. So again, this is the same thing. This cell is empty. Why? There's no column to the left of me. There's no row above me. This cell is not empty because there's a column to the left of me. So getting that. This one is not empty. There's a column to the left of me. This one would have been empty if I just wrote previous sales amount on columns because there's no column to the left of me. But since I wrote columns rows, I'm allowed to take the value of the previous row, the last cell, and put that in here. So this snakes across your visual matrix in a Z pattern. Why would you use this? You would only use this in very specific scenarios. For example, when you have years on the columns and the quarter number or the month number on the rows, and you want to do, for example, running sum in the year or a moving average in the year over the last 3 months, for example, you need some kind of snaking pattern. But otherwise, you wouldn't use columns or rows and columns to combine. You would probably just use rows or just use columns. So then let's talk about reset, and then we can open it up for questions. So reset allows me to decide what happens when I traverse the visual matrix. So by default, it's set to none. That means that the calculation never restarts. But you can change it to say, I want to restart on every new year. So what does that mean? That means for every single time that the year value changes, I'm going to restart the calculation from 0. And you can write, for example, running sum sales, comma, year, to say, I'm doing a running sum of sales, but I'm restarting for every single year. You can also write highest parent, lowest parent, or a number to be more flexible than just specifically writing the field name, to just refer to what's on the axis you're moving over. But let's stick with the running sum sales, comma, year example. Now, why is this interesting? Well, if you have multiple years and you're doing a running sum, if you just wrote running sum of sales, your running sum is going to keep counting for all the years. So let's say you have quarters and years, then probably your client's expectation and your expectation is actually that your running sum would restart for every single year, right? Like after the fourth quarter ends, you probably want the running sum to start over again from 0. So you want your running sum to actually calculate within the year. So that's where reset comes in. So if you write running sum sales, comma, reset year, that means do the running sum, keep adding values until the value for year changes. If so, start from 0 again. And then your running sum will calculate within the year instead of going across the years. So I'm going to show you how that works real quick. So I'm going to change, I'm going to change this chart. So I'm going to create another one. I'm doing a simpler one with sales and quarters. Okay, so I have this now. Let me just do this. Whoops, that's not what I wanted. Okay, that's better. Cool. So this is now a run. This is not a running sum at all. This is just a chart. And now I can do running sum of total sales, right? So what this will do, since it's not resetting, it will keep counting. So as you can see, the line will grow and grow and grow and grow and grow, which of course that's what a running sum would do. But since we have multiple years, we probably want to restart the calculation at this point for the new quarter, for the first quarter of the new year. You want that to start over, grow until Q4, and then for 2020, Q1 start over again and grow again. So to achieve that, what you can do is you can say total sales, and this is where you would be using reset. I can actually go and use reset and say, I'm going to reset for every fiscal quarter. Now, by doing that, now you will see this line grow and grow and grow until it's a new quarter, the first quarter of the new year, grow and grow and grow, and then start over again, right? So this is how reset changes the behavior of your running sum calculation. You can use it for any of the calculations that we have, but running sum is the easiest to understand. Cool. So that's all I had to share about visual calculations. Before I open it up for questions, there's much more to explore, much more to discover. Please read the docs, give feedback, try this, and if you want to learn more about the functions that I showed you, there's lots of information about our on our page, of course, on our Learn page for the DAX documentation. There's a specific article about order by, petition by, and match by. So with that, thank you, and if you have any questions, please let me know.
Yes.
Yes.
Thank you very much, Jeroen. Really, this was the topic that I was much more interested in, and thank you for just delivering this speech. Really, it was very useful, very amazing. Before each session, I'm gathering questions from my members. So, three questions I have already pasted in chat.
Yes.
If you don't mind, please go on with this question. And one more question is coming from Noah Pesky, and I myself also have some questions. We'll ask you. So,
Okay.
please.
Yeah. So I think the first question you posted there is what limitations exist using visual calculations compared to DAX measures, right? And I think there's a whole bunch of limitations, right? We are still working on this. This is still in preview, so you cannot use it for many situations yet. There's a lot of visuals that we don't support yet. You cannot use this in publish to web. So I would go and read the documentation to see all the limitations. I think the question behind this question is actually slightly different. It is about reuse. So I talked about visual calculations, and they are part of a visual. So what happens if I want to have the same exact calculation in another visual? A measure is really reusable. You can use it, you can write it once, you can use it, reuse it everywhere, right? And so this is where they differ. So visual calculations will require you to copy paste the calculation onto the other visual. So this is a limitation of visual calcs. It's kind of by design. We were thinking about how we would allow you to reuse a visual calculation across visuals, but today the only answer is you can copy paste the visual calculation. It's not great, I agree, but you sacrifice flexibility and reuse of measures for ease of use and performance, because visual calculations are faster than measures. They should be faster than measures. So that's kind of the trade-off you're making. I hope that
Thank you.
that answers that. So how do visual calculations interact with slices and filters? Well, they are dynamic as measures. So unlike calculated columns, they will just react to a slicer or a filter like your measure does, right? So I can show you that, in fact. If I go out here, whoops, where's my mouse cursor? Come on, there we go. Okay, so in here, I have my chart here, right? I can now say, okay, I'm going to add a slicer, and that slicer will be on, let's say, fiscal year. And if I change the slicer to say only this, then you will see that indeed my chart and my visual calculation update. Why? Because visual calculations only work with what's on the chart. So since the information that on the chart that's on the chart changes by me selecting something in the slicer or setting up a filter, hence the visual calculation is only aware of that information, right? It doesn't know anything about it. It doesn't care how it is changing. The only thing it knows, it changed. So then the visual calculation has no other option than change its result as well. So if you look at this, if I only select one fiscal year, then of course, whoops, I need to actually select one fiscal year. Then of course, if you go into this visual calculations mode, you will see that I'm correct in saying there's only one fiscal year that the visual calculation is aware of. This is the only stuff that it knows about. So it has no other option than to actually change its value. So that's really what this is. Okay, cool. So best practices for combining visual calculations with traditional measures in a report. I think I already alluded to it a little bit. You basically, I would use visual calculations for everywhere where you have this one-off measures that you only use on a couple of visualizations or one visualization. Many of those exist. I would replace them with visual calculations in a heartbeat. I would also use visual calculations for performance reasons when you know that the query you're generating in a measure is very tough, especially if you use direct query. You can benefit from performance benefits with visual calculations because they execute on the client side, so they don't go back to the source all the time. So that will make it faster. I would also use visual calculations instead of measures when, for example, I need to do stuff like running sums and I don't want to write the complicated DAX, right? So that's how I would combine those.
Thank you. The next question is coming from Noah Pesky. It's yes.
If I deselect the parameter used within a slicer, the running totals are broken. Yes. Reselecting the parameter in the slicer does not fix that. That should, I think, okay, so Noah, that should not have happened. So what he does, I think, do I have a parameter here? No, I don't. But yeah, you're right. So a parameter allows you to, can I quickly create a parameter? So I'm going to call this parameter running cost and sales. I'm going to put in there, and I'm just going to call this parameters. I'm not going to even change the name. So I think what Noah is after is the following. I put my parameter on here. So then in here, I'm going to refer to my what is it, cost. Okay, so that's projected by my parameter. So then I'm going to get rid of total sales. So by doing this, if I project a different parameter, so cost should work. If I project a different parameter, then my visual calculation will break. Why is that? Well, because the visual calculation is only aware of what's on the visual. So the parameter has now stopped projecting cost, and as a result, this running sum cannot operate because, well, cost is no longer there because it only contains sales now. So, but it should work by just putting it back. So this is a by design limitation, right? Because we haven't introduced a meta programming yet that allows you to say whatever the visual the parameter projects, that's the field that I'm referring to. That kind of flexibility doesn't exist. This only is a problem, by the way, if you have field parameters that change the measures. Because of course, if you have a field parameter that changes what is on the columns, then that would not be a problem because your visual calculation does not have to refer to those columns explicitly. You can just refer to rows and then take whatever is on rows and do the calculation on. So this is a problem. This is a challenge with using visual calculations and parameters together. You're right. But the same problem kind of exists with measures, by the way. Same problem. So other questions? How do visual calculations? Yes, sorry, go for it.
No, please, just go. How do
So
visual calculations interact with row level security in Power BI? Sorry for interrupting you. Yes.
No worries. So row level security, of course, changes the data that you can see. So the same, right? The same applies as a slicer. If you have a row level security rule that limits the data that you can see in your chart, let's say you can only see, I don't know, Canada data, then your visual calculation can only see Canada data. So the row level security is used and applied in the visual calculation as well. It's not special, right? Think about the visual calculation as it can only work, it is only aware of the data that the visual works with. So to rethink this question, it's more of a question, does the visual respond correctly to my row level security rule? If it does, then my visual calculation will respond correctly as well, because a visual calculation only knows what's in the visual, nothing else. It's not aware of anything in the model. It only works within the visual. So does your RLS rule change the data in such a way that it shows the correct data in the visual? Then your visual calculation will respond correctly as well. I hope that answers that question.
And last question, how
Yes.
do visual calculations handle blank or missing data in a report?
So visual calculations do the same as a visual does today, right? So by default, they will not show blank data, right? So a visual by default doesn't show any empty rows, right? A visual calculation will not do the same, right? Will do the same. So if you tell this to show where is it? To show items with no data. Why can I not? Oh wait, that's a parameter. That's why. Okay. Get rid of that. Okay, so if you change this to show items with no data, your visual calculation should continue to work just fine, but it doesn't do anything special. Again, it's up to the visual to handle this. So as long as your visual responds the correct way you want it to respond to blank or missing data, you can the visual calculation will do that as well. Now, if you have sorry about that. If you have your empty axis on your empty values on your axes, you can actually sort that out, right? So as you can see here, it doesn't show the blank for fiscal year, right? That's the matrix doesn't do that. But if you had it on here, you would actually be able to tell visual calculations to sort your axes in a certain way. So you can say, I want to put my blank value for fiscal year at the top or at the end. So you can move this blank value around to change how this calculation operates. So that's how you can refer to that. And in a visual calculation, there's actually a parameter here that allows you to specify that. My data set is nice because it doesn't contain any of these, but you can say, I'm going to do a running sum, and then axis is an optional, right? So that's rows, right? As you can see, then you can see the little icon as well. And then I can write blanks and say my blanks go first, right? So I can move the blanks to the top, which is not sorting the blanks value in the cost. it is sorting the blanks value in this, right? So on the X that is specified, the rows, what is the thing that is now, where do the blanks go? So if there's any blanks in here, so there was a blank here in here, where do I put that? Do I put it at the top or at the end? So then I can write this and say, okay, this, doesn't change anything. It wouldn't do anything useful, but hopefully that explains how you handle blanks.
So that's it. We came to the end of our session. Thank you very much for your wonderful session.
Yep.
Valuable information, really, we got. So I also appreciate those who sent these questions. So that's it. I hope I will see you in near future in US.
Yes.
So and one little secret. I'm just going to organize a 1 or 2 day event in Azerbaijan. Actually, some Microsoft employees, when I was in London, they also wanted to come, and I will be very happy, of course, to see you in my lovely Azerbaijan. But of course, till that time, a lot of stuff to do. Yes, that's
Oh, I
it.
mean, that's
Yeah,
that's exciting. I would love to.
yeah,
I'm not often in that part of the world, so if there's a conference you're putting together, keep me posted. That would be very interesting.
exactly, exactly.
Yeah, absolutely.
So
So happy to. And then I'll see you at the MVP Summit for sure. And anybody else
exactly.
that is on the call and watching this, I'll hope to see you at some point at a conference anywhere, regardless of where in the world. And then
Yeah,
I'll yeah, please say hi when we meet.
exactly. Exactly.
Okay,
And
thanks a
it
lot.
was also great to work with you when I was in Sweden, even for 1 or 2 hours.